This is exercise 25, once again dealing with special senses, specifically with hearing and equilibrium. With hearing, obviously we're going to be looking at the ear. The ear is divided into three major parts. You have the external, the middle, and the inner ear. All three of these parts are involved with hearing, and the inner ear is also involved with equilibrium. With the external ear, there are different components of it. And some of these, as you will notice, have multiple names. We start first with the auricle or the pinna. This is the outer portion of the ear that you see. That purpose is to funnel all the sound waves into the next component, which is the external acoustic medius or the auditory canal. That canal goes from the auricle to the eardrum. And so the auricle or the pinna, what most people would refer to as the ear, is funneling the sound waves, directing them into the auditory canal, which is then going to extend to the tympanic membrane or the eardrum. The tympanic membrane is that division between the external ear and the middle ear, and it's going to vibrate when the sound waves hit it. In this diagram here, you can see on the upper portion the entire ear, and then in the lower portion, it's focusing on just the end of the external ear where the tympanic membrane is, and then it shows from there the middle ear, which contains your auditory ossicles, which are the bones in the middle ear, the malleus, the incus, and the stapes, and then how it connects to the inner ear, which does contain the semicircular canals as well as the cochlear, and they will be sending the nerve impulses by the cochlear nerve and the vestibular nerve. In the upper picture, you can also see the pharyngotympanic or auditory tube, also known as the eustachian tube, that drains from the middle ear down to the pharynx area. So the middle ear is a chamber. It should be filled under normal conditions with air, not any fluid. The tympanic membrane or eardrum, as it vibrates, it's going to send or transmit those vibrations to the auditory ossicles, those bones in the middle ear, which, as we said earlier in our list here, the malleus, the incus, and the stapes. What's going to happen, it's going to amplify the sound. So you can see here the three bones, and how as one of them gets stimulated by the tympanic membrane, then it will start to vibrate, and then it will vibrate the next bone, etc. So first it vibrates the malleus, then the malleus gets vibrating, which will vibrate the incus, which then gets vibrating and will vibrate the stapes. The internal ear is divided into different components. You have the bony labyrinth and membranous labyrinth. The bony labyrinth contains perilymph. The membranous labyrinth contains endolymph. Within the bony labyrinth, you have the vestibule, which is composed of the sacral and the auricle, and then the semicircular canals and the cochlea. It is in the cochlea, which is where the receptors for hearing are actually located. So in this diagram, it's focused in on just the inner ear. As you can see, there are three different semicircular canals and different orientations. This is going to help you with balance and equilibrium. And then in the cochlea, it looks like a clam or a snail shell, and it's twisted in that circular fashion, and that is going to contain, as I said, the hair for the hearing receptors. So this is shown certainly enlarged of the cochlea, where you have the different vestibules and then nerves extending from those vestibules, extending out, forming the cochlear nerve, which is going to be part of the vestibulocochlear nerve, or nerve number 8. For hearing, what's going to happen, as I said earlier, the sound waves, they're going to funnel in to the auditory canal or the external acoustic meatus, triggering that tympanic membrane to vibrate. As it starts to vibrate, it causes the ossicles to vibrate. They're going to amplify those vibrations. The stapes is connected to the oval window, which is the division between the middle ear and the inner ear, and it's going to cause that oval window to start to vibrate. The waves generated from the oval window vibrating are going to move through fluid in through the vestibule of the cochlear duct. It's going to get the basilar membrane to start to vibrating, and then that is going to stimulate the hairs to start to vibrate, and that's going to be the stimulus for the hearing. And this diagram is just showing as the sound waves move through from the outer ear. You can see as it moves in the inner ear, it becomes amplified, remains amplified in the inner ear. So in order to hear, you are getting impulses from both ears. That's going to help you to localize where the sound is coming from. Each tone is going to be perceived separately. And then the brain's got to analyze in the hearing section. It will analyze the tone, the location, the pitch, etc. For equilibrium, the equilibrium receptors are located in the semicircular canals and also in the vestibule. All are contained within the inner ear. The vestibule kind of monitors acceleration and head position relative to where gravity is. And then the semicircular canal, because remember there's 3 of them in different locations, they can help monitor the rotation of the head. In order to maintain balance, obviously it's associated with equilibrium, and there's several different factors that are going to be involved working together here. So you have the receptors in the inner ear that are noticing being stimulated, noticing the positioning of the head relative to gravity, relative to the rest of the body. It's going to be sending that input to the cerebellum. But in addition to that, you also have visual receptors. What are you seeing? Can you see that you're upright, or can you see that you're tilted? That's also going to be sending impulses to different areas of the brain. This cerebellum is going to be sending it to the vestibular nuclear complex. And then you also have receptors often in joints that are helping you with equilibrium and positioning, stability. And that's also sending impulses to areas of the brain to help you process where are you in terms of being upright. Are you falling? Are you at a slant? So once again, you see where the body doesn't work just one little component by itself. You often have input coming from several different places. It may involve several different senses, several different systems even, all working together to maintain, in this case, your balance, your equilibrium.